Hello, developers. So let's see what you have here. Write a function, max value, that takes in a list of numbers as an argument. The function should return the largest number in the list. Solve this without using any built-in list methods. You can assume that the list is non-empty. Good. One problem is already solved. We don't have to check if the list is non-empty because we've already been inserted here. We can assume that the list is non-empty. Now we can jump straight and create a function called max value that takes in an argument nums. Once we have the function, we need to ask ourselves, how are we going to know the maximum value in the list? We need to compare each item against each other in the list. And for us to achieve that, we have to keep a snapshot of what we've already compared and store it somewhere. We're going to create a variable called maximum. You can call it any name and assign it the smallest value in Python. Negative infinite. Now that we have the smallest value, we are very sure that all the items in the list that we've been given is going to be greater than the maximum. So it is just a matter of comparing each item with the maximum value. If we find any item that is greater than maximum value, we update the maximum. Now we are going to loop over all the items in the list. For num, in nums, we are going to check if num is greater than maximum. And if we find a value that is greater than maximum, we update our maximum, the value that is already there. Okay, this loop is going to continue until the last item in the list. And if we find any item that is greater than maximum, we are going to update maximum to take up that value. We get out and return our variable that is holding our maximum value called maximum. This is going to return the maximum value because each time we loop over and you find a num that is greater than maximum, we are updating it. Now let's call this function called max value and give it a random array. You can say you can give it 4, 7, 9, 23, 12, and 78. Let's run and see, because from what you can see, 78 is definitely the max value. So let's wrap our function inside print so that we can have the result printed on the terminal. We save, then we run and see. Yeah, 78 is definitely the answer that we expected. Now, let's change 78 and make it 8. What do we expect now? We expect 23 to be the maximum value. Let's save and run. Yes, it's 23, just as we expected. Because we're looping over all the items in the list. So the bigger the array, the more time it's going to take. The smaller the array, the less time it's going to take to run through each item. Now we are going to see the big O of this algorithm is going to be linear. Big O of n. And for the space complexity, because we don't have any other space that is being created while running the algorithm, we are only changing the maximum value, which initially it was initialized as infinite negative, which is the smallest number in Python. Now every time we change, it is going to update the maximum. So because of that, no space is being created. The space complexity of this algorithm is going to be constant, big O of 1. Thank you so much for watching this. I'll catch you in the next one. Bye bye.